Alright guys, so today is the last section of Unit 3, yay! So we're finishing up our matrices unit. So today we're going to be talking about identity and inverse matrices. So let's talk about what an identity matrix is. An identity matrix is a square matrix that has ones along the main diagonal and zeros everywhere else. So the main square matrices that we're looking at is a 2 by 2 and a 3 by 3. I'm not going to give you any bigger matrix than that. So the main diagonal would be the one that you multiply first, and zeros everywhere else. So that's a 2 by 2 identity matrix, and the 3 by 3 would look like this. So it'd be 1, 1, 1, and then zeros everywhere else. Okay, now a fact that you need to know: the identity matrix is always the matrix you multiply by to get equivalent numbers. So it's like multiplying by 1. So whatever matrix you start with, when you multiply it by the identity matrix, you're going to get the original matrix. So let me do an example of this for you. We're going to do a 2 by 2 just because that goes a little faster. Okay, so let's say that the matrix that I'm given is 2, -4, -7, -1. And I multiply it by the identity matrix. Now remember, this is a 2 by 2, this is a 2 by 2, so our answer is going to be a 2 by 2. Okay? Now, please remember that what you're going to get, how you're going to do this, is you're going to multiply the first row by the first column. So 2 times 1 plus -4 times 0. Then the first row times the second column. 2 times 0, -4 times 1. Then -7 times 1 plus -1 times 0. Then -7 times 0 plus -1 times 1. Okay? And that's going to give you let's actually come over here and do the next part. Okay, so this is going to be 2 plus 0, 0 plus -4, -7 plus 0, and 0 plus -1. So my answers are 2, -4, -7, and -1, which, if you pay attention, is the same as the original matrix. Okay? All right. Now, going to inverse matrices. When you multiply a matrix and its inverse, you're going to get the identity matrix. So when you multiply two matrices that are inverses of each other, you're going to get that 1, 0, 0, 1. Or the 3 by 3 that has the ones in the diagonal. Okay? So the question that they're going to ask me right here is, are 3, -1, -5, 2, and 2, 1, 5, 3 inverses? So all that I need to do, no ma'am, is multiply these two matrices together. My dog is getting very curious and she's finding trouble. All right, so here we go. Times the 2, 1, 5, 3. Now, this is 2 by 2. This is 2 by 2. Those match, so that means this will work. And we will get a 2 by 2 answer. So this is 3 times 2 plus -1 times 5. And this is 3 times 1 plus -1 times 3. This is -5 times 2 plus 2 times 5. Then -5 times 1 plus 2 times 3. All right. So let's see what we got to work with here. So this is going to be 6 plus -5. This is going to be 3 plus -3. This is going to be -10 plus 10. And -5 plus 6. Which results in 1, 0, 0, 1, which is the identity matrix. So the answer to this is yes. Okay. That check mark looks awful. Let's try that again. I know that that's not important, but kind of is to me. All right. Yes, they do work. All right. So determine whether each pair of matrices are inverses. It would have been great if they gave us a lot more room to work. So we're actually going to work this one up here, and then we'll work this one up here. Okay, so we're going to do 3, -2, -1, 1 times 1, 2, 1, 3. Again, a 2 by 2 and a 2 by 2. means that my answer is going to be a 2 by 2. Alright, so here we go. So 3 times 1 plus negative 2 times 1. 3 times 2 plus negative 2 times 3. Alright. Then negative 1 times 1 plus 1 times 1. Then we're going to do negative 1 times 2 plus 1 times 3. Alright, let's see what that gives us. On this first line, that gives us 3 plus negative 2. Second piece gives us 6 plus negative 6. So far, so good. It's looking good. This gives me negative 1 plus 1. It's looking real good. This gives me negative 2 plus 3. And that should have been in green, but here we are. So my answer is 1, 0, 0, 1. So the answer is yes. So my money's on this one's probably going to be no, but let's do it anyway. Okay. So again, here we are. We have 3, negative 1, 4, negative 2 times 1, negative 3, 2, 4. All right, so we're going to do 3 times 1 plus negative 1 times 2. Then we're going to do 3 times negative 3 plus negative 1 times 4. Then we're going to do 4 times 1 plus negative 2 times 2. Then 4 times negative 3 plus negative 2 times 4. So this is going to give me 3 plus negative 2. That's looking good so far. This is negative 9 plus negative 4. Wait a minute, I don't need to be using that color. I should be using this color. Negative 9 plus negative 4. And then this one is, I'm struggling with my colors today. This one is 4 plus negative 4. And this is negative 12 plus negative 8. So the first column's pretty strong, because that's a 1, that's a 0 like it should be. But this is negative 13, and this is negative 20. So the answer to this one is no. Okay? So they are not inverses. All right, next. Now, not all matrices have an inverse. So how do you find out how do you find an inverse matrix? To find the inverse of a 2 by 2 matrix. Okay. First, find the determinant. If the determinant is 0, the inverse does not exist. So the first thing you do is find the determinant, okay, to see if it even exists, okay? And if it's 0, it doesn't exist. But then you're going to come down here after you find that determinant to find the inverse, okay? So I'm going to get my highlighter here. Okay. So this means the inverse of A. Okay, you're going to find the determinant of the matrix, then multiply it by the main diagonal swapped and the opposite of B and C. Okay, so this is a formula you just got to learn. There's just no other way around it. So the inverse of a matrix is the reciprocal of the determinant. That's what the 1 over means. Okay, so if you get 2 for the determinant, this number is going to be 1/2. Okay, if you get 1/4, then the number right here is going to become 4. That's going to be your scalar. Okay, times the matrix with the main diagonal swapped and the other terms multiplied by -1. So that means make them the opposite. Oops, and you can't see that. All right, so if you need to pause that, feel free to do so. All right, here we go. We're going to do 3 examples of this. Okay, so the first thing I'm going to do is I'm going to label this A, B, C, D. Okay, so the first thing I'm going to do, step 1, is to find the determinant. And that's going to be 3 times 2 is 6 minus -5 times -1 is 5. So the determinant is 1. Step 2, do the reciprocal of determinant. So that's going to give me 1. Multiply step 2 by change matrix. Okay, so I'm going to put 1 times, remember we switched the main diagonal, and then change the signs of the other 2. Okay, so that my my inverse matrix, if I multiply each of those by 1, gives me 2, 1, 5, 3. And if you wanted to check this, you could multiply this by this, and it would give you the 1, 0, 0, 1. So I'm going to put a note here. I'm not going to do the check. Can check by multiplying A and A to the -1, which means the inverse, to get 1, 0, 0, 1. Okay. All right, here we go. Let's do another example. So step 1, I'm going to get the determinant. So this is -8 minus -10. Remember, 2 negatives together make that a positive. So this is going to become a 2. So the reciprocal makes that a 1/2. So you flip it. Step 3, you do 1/2 times the changed piece. So that becomes a 4. This becomes the -2. This becomes a -5. This becomes a +2. So this means that my inverse matrix is, what's half of 4? 2. What's half of 2? 1. What's half of -5? If you need to type that in, you can, but that's -2.5. What's half of -2? -1. And you could do the multiplication there to check. Oh, that's a B. Helps if you know your letters, Miss Evans. All right, here we go. Let's do this last one. Let's find the determinant. So -12 minus -12. So this becomes a positive. This is 0. Bells should go off in your head. Determinant is 0. So inverse is undefined because think about what you would have to do next. You would have to flip 0. So that would become technically 1 over 0. You cannot have 0 in the denominator. So that's why it goes kaput. Okay. And that's all that there is for today. So let me know if you have any questions. Have a good day.